Testing, 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 testing. All righty. So let me make sure that I have everything here. Just going to open up another sheet, but here I go. So I wasn't going to do all of the other things for you guys. I'm expecting you to know how to do it. So I'm expecting you guys to know how to do it pretty much yourselves. So you'll see that I actually have my probability distribution here, and I most likely got rid of the outliers, so it is pretty. And then I have 60 here. It is pretty. Okay, so you'll see it's at 480 microseconds, and then I'll have 70, and right here I don't have this, I don't have anything for this one, so I need to go and get the time for that one. I'm just going to copy this title, and I'm going to go over here, and I want to show you how to get the time. So I'm just going to say paste, and I know it's not at this second, and so, and I don't have my X and Y, my horizontal, primary horizontal and primary vertical. So let me show you where to get that from, okay? Yes. So this is my science journal. And this is all of the information. So this is the 50 raw count. And this was my delta. If you see this, this is 400 microseconds. And that's my delta time, my pulse width. And so I just reduced it, and it's still giving me the same pulse width. So you look at your delta here, that's 400 microseconds. And then, let me see, I'm just gonna go ahead and keep going. So now, that's 50. So now I'm about to do 60. So 60 is right here. You'll see we have 480. So you have access to this document. Even though I'm going through it right now, you still have access. And then 70, right here, that's 560 microseconds. So let me just go back to Microsoft Excel. So we know that this is 560 microseconds, and we have our angular velocity here. Remember that this is in rads per second, all right? So that was angular velocity in rads per second. And then I'll just go over here and change this one to normal distribution. All right. So I'm going to go ahead and go to 80 and just do the same thing. And I know that, so I have, let me see here. So here's 80 coming up, and this is 640. $640. And you guys just make sure you label everything. Make sure you take care of all of your axes. You'll see on 90, I still need to do the same thing, so you make sure you do it, okay? And what I'm gonna do is I'm gonna open up a new sheet here, and I am gonna call this model verification. For students. So let me see, the first thing I wanted to do, the model is going to be basically our mean of our angular velocity. Let me see if I can make this a bit bigger. So it's going to be the mean of our angular velocity, and we can also do this in terms of the time, so, or the raw count. So I'm going to put raw count, I'm going to put time, and I'm going to put the what else is it? Raw count, time, and angular velocity. So let me just go ahead and get this last raw count at 90. And this one is 720. So we'll at least have that in. So we know that this is 720. I'm going to do my best to make this one, make it nice. So we'll start off right here. I'm going to go ahead and make this big. We're now looking at regression analysis. And so we're trying to build a mathematical model. I always want you guys to know how to do that. And so we start off with, let me see, let's do, since the control is like a raw count, we'll put that on the x-axis and we'll put angular velocity on the y-axis, all right? And we can do the same thing for time. So I'm gonna say raw count. And once I have raw count, I'm gonna have how you doing there, sir? I'm doing really well. I'm doing really well. I was